This is Mr. Curtis, and this is about polynomial addition and subtraction. The key to this is trying to write an equation that is simplified by combining like terms, but if you were to substitute something in for x and something in for y, then this expanded version would equal the same thing as the simplified version. Here are three examples. I'm going to go through all three. Okay, so you can copy this down into your notes, and then I'll show you the steps. Pause if you need to. Okay, first step is let's write it without the parentheses. Can I combine these? No. Is there anything to multiply across? No. So 3x squared minus 2y, and then plus, there's just one of these parentheses, and since it's positive, I don't have anything to distribute. So I'm going to say this is plus 4y, and I can't combine it with anything else, so just plus 10, and then minus x squared. Look for like terms. Well, like terms would be 3x squared, and this is a minus x squared. And how many of them, though? There's just one. So this is 3x squared and minus 1x squared. Those combine to make 2x squared. That was just simply 3 minus 1. Look at the coefficients. The coefficient of this was a 3. Coefficient over here was an invisible 1. But I combined them because they have the same variable, an x squared and an x squared. Okay, so those combine to make 2x squared. Now let's see what else. I have a negative 2y and a positive 4y. Those combine because they're both y's. So let me look at the coefficients, which is the number in front. A negative 2 and a 4 combine to make positive 2y. So I've used that, I've used that, I've used that, I've used that. I crossed these out just to make sure I've used everything. Oh, I still have a positive 10 left, and there's nothing I can combine with right now, so I just put plus 10. So this is my term. Pause, write that down. Okay. I'm going to show you what I meant. This term is the same as this. I just combine like terms. What I mean by the same is, I mean it's equal. I could plug in something for x and maybe a different number for y, and it should give me an answer. And that answer should be the same as if I took that same x and plugged it in for all of these x's, and the same y and plugged it in for these y's. I'm going to show you what that looks like. You don't have to write this down. You can just look at this. Okay. If I used x is 3 and y is 4, x is 3, y is 4. Okay. This is the equation we came up with after simplifying it. It was 2x squared plus 2y plus 10. When I plug in a 3 for x and a 4 for y, I get, let's see, 9 times 2 is 18. 2 times 4 is 8, and plus 10. 18 plus 8 plus 10 is 36 when I plug in a 3 for x and a 4 for y. If I were to keep it original, 3x squared minus 2y, that's 3, parentheses, 3 squared, minus 2 times 4, plus 4 times 4, plus 10, minus 3 squared. Again, that's me plugging in a 3 for x and a 4 for y. And when I simplify this, it becomes 19 plus 15, which is 36. So what we're really dealing with is equality. Can I rearrange an equation to make it look different, but it still be equal? Meaning, can I plug in x into both things and it work out? All right, let me do another example. This one is subtraction, and I like to get rid of the parentheses first, okay? So pause, write this down. You're going to need to. Okay? So again, I say step 1 is work out parentheses. Work out parentheses. Okay, so can I combine a 10p, a minus 4q squared, and a minus q? No, they're all different variables, so there's no number out front to distribute. So I just simplify that as 10p minus 4q squared minus q Here's another parentheses, but I actually do have something to distribute out here. This is a negative 1, which means I need to subtract everything in here, not just the first term, but everything. So it becomes a minus q squared, negative 1 minus 3p. Remember, it's multiplication, so negative 1 times a negative makes a positive. So this actually becomes plus 3p. Negative 1 times positive 8p squared becomes minus 8p squared. Now I look for like terms. Let's see, here's a p and here's a p. Let's see, there's a p squared, no other p squareds. Let's see, there's a q squared and a q squared, and then there's just a q. So I'll start with the highest I have first, and that's the negative 8p squared. Notice I take the negative sign with it when I move it. So I'm going to write it first. Negative 8p squared, and since I've used it, I'm going to cross it out. And now I have minus 4q squared and minus q squared. That's negative 4 minus 1. Negative 4 minus 1 is negative 5q squared. I can cross those out now. Let's see, then I'll do the p's. 10p plus 3p, they're both positive, so that becomes positive 13p. I can cross those out because I use them now. And I have left is a minus q, so I'm just going to write minus q. And I'm done. That's my answer. Work out the parentheses, step 2, distribute negative if needed. We needed to distribute the negative to everything in here. Otherwise, we would have gotten the wrong answer. Okay, so please pause. Write these 2 steps down. Step 1 and step 2. Okay, unpause. Just one more quick example. 4a minus 3b squared minus a plus b minus 6 plus 9a squared. I want you to work this out on your own and write the answer in a box on your page. Okay, your answer. Hint, you don't need to change anything in here like we did on the last one. So look for a's. Oh, you actually can combine those. You won't be able to combine a minus 3b squared, and I won't think you'll be able to combine these things. But you should write your squareds, okay, whatever, your a squared term should come first. I'll give you a hint. 9a squared is going to come first. And then there's going to be other things, b squareds and b's and a's and just numbers. So write your answer in a box on your paper so I can come by and check it. When you're done, raise your hand, and I'll come check your work. Thank you.